Here's an easy question. Who have been in an airport in the last 6 months? Yeah, that was an easy one, no? Who had suffered delayed from a potential flight? Yo, see, that's the thing. So the whole point of this project is getting into that kind of reality. So yeah, we don't really want to spend like 5 hours waiting for a flight that might never come, either for ourselves or maybe we have kids, no? And this is kind of a nightmare. And usually, well, if the flight is delayed, it's because it's not going to get through. So yeah, why can't we really find a simple, accurate, artificial intelligence driven prediction that can help you really get through that in a better way? Basically, we cannot really try and really trust the airlines to give us this information. When they give us a flight status, they usually kind of manage our own expectations to make sure that we are like easy, nice, quiet passengers. But there is a ton of data that exists online. And actually, this kind of data is the one that loves machine learning, deep learning models to get through solutions. And actually, yeah, that can really help avoid bad airlines in the first place. So if you know what kind of predictions you get, maybe you won't buy this specific tickets for that airline, but from another one. No? So managing your expectation at the moment, but also beforehand. So yeah, let's look at the demo. So can we switch to the website? Yeah, let's open a simple browser. Actually, it's just not fake. It's a real website, obviously. It works. You can access it from your own laptop or mobile phones. Willitfly.info. This is how it looks like. Fantastic. So, Birke, I think you have a flight tomorrow, right? So you're flying to Mallorca. Lucky her. So let's type in the flight number and just let shoot. You see? So we're sending the flight code as a simple information to the system that will then retrieve a lot more data out of it and pass that to the model that we have trained. And then we just have, as for demos, wait for the solution. And yeah, well, good for you. The flight is on time. You have the flight information and you have also like the percentage, the probability of the flight being on time or delayed. No, so it's a bit white, but you can easily test on your mobile phone and see the same experience. That's how it works. It looks really simple, no? One code, one result, a few seconds to wait, not even, and a good prediction. But basically, there's a lot more behind. And yeah, Burke and Sol will explain. So from data to the model, to how it works online, to the experience that you've seen. Basically, what we started doing is harvesting a massive amount of data online that doesn't exist. It's usually property information. So from the flight information, the airport arrival, the weather, etc., and passing that to the model in a way that is understandable. So Burke, up to you to explain the data processing. Thank you.
Yeah, thank you, Julian. Hello, everyone. My name is Birke, and I will explain the data part of our project. So what do we have for our data? We have the historical flight information that consists of the departure airport, the arrival airport, the airline information, and the date and time of the flight. And on top of this, we have the airport and airline rankings based on the customer opinions and based on the on-time performances. So as another data type, we have the weather data, meaning when this flight took place, how was the weather like? So that being said, here you can see the different data points or features that we have. And we can divide these into two categories. We have the numerical features and the categorical features. So numerical features, as the name suggests, they are formatted in a number format. And the categorical features, such as airline, they are formatted in a text format. So now that we have all this data, the historical flights, the rankings, and the weather, now we need to prepare it for the model. So this process is called pre-processing, and it's all about making sure the data is in a format that the machine can understand and learn from. So why pre-processing is important? Looking at the data set, we might instantly derive some meaningful information from it. For example, on Sunday, late evening flights well, they are more prone to be delayed because there is higher travel demand, right? But however, our model needs clean and structured information. So our job is to convert this raw data into something meaningful for the model. So one example is the cyclical encoding that we did. So humans naturally understand the cycle of time. For example, we know that Monday is followed by Tuesday and December is followed by January. But the model doesn't know this. For a machine learning model, these are just random numbers. So for it to grasp the time as a continuous cycle, we need cyclical encoding. And then another encoding that we did was the converting the categorical features into numbers, because the models doesn't like text, they like numbers. So this is how we selected our features. This is how we went from the raw data to the pre-processed data. So now the model understands the seasonality. The model understands that the airport is a categorical feature. And here, as an example, you can see, so this is a flight, a specific flight, and we can see the why after all this pre-processing and after training the model, meaning after our model learned from the data, then we come up with this. So why this flight will be late? You can see the airline was the most predictive feature that says this is prone to be delayed, which is Transavia. Apparently, it's an airline that's prone to be delayed. Yeah, and then you can see the arrival airport is also a predictive feature, and then, I don't know, like weather, so on and so forth. So this is the data part. Now I will hand it over to Sol for the model.
Thank you, Wodka. Hi, I'm Saul, and basically I'll just be explaining a little bit about how we actually made the model that would predict eventually if a flight was delayed or not delayed. So just to give you a bit of context behind it, the first target we had, which is what we want to predict, was actually the delay in exact minutes. So for example, 10 minutes delayed. We even had ones that were about 400 minutes delayed. And we first tried, what we wanted, to basically get a prediction that would tell the user exactly how long their flight would be delayed in minutes. We tried to model in a regression model, which is this kind of example here, which uses numerical data. So what Burka explained as being numbers. We found that with the amount of data we had in the model, that it wasn't really working as we had planned. So we if we had more data, it probably would have worked, but we actually shifted the concept to a classification model, which is this concept here, which basically, in the target, which used to be the minutes and delay, would basically just simplify it a little bit and just be basically delayed or not delayed. So delay being 1, not delayed being 0. And this, what it does is it allows the model to basically see that, okay, all the features, all the flights that are delayed, what are the features and criteria that are creating those delays, and sort of divides the data like that, which allowed the model to understand it a little bit better. And then basically we used a model called CapBoost Classifier, which is a classification style model. And obviously the model itself, the algorithm, has already been produced for us, and we can implement it with this code, for example. But of course, it's not trained on anything. Training meaning that it needs to learn from a certain type of data to actually make predictions on that data. So for example, we gave it all the data, which as she explained, was pre-processed, so the machine could actually understand that data. And then we had to put some features in called hyperparameters, which are basically, imagine if you have a large machine with 1,000 switches, and depending on which switches you turn on and off, the machine will work in a different way. Obviously, this is very complex. That's why we use another algorithm called a grid search, which goes through this process and automates it for us. It's very computationally expensive. Well, it takes a lot of computing power. So with the resources we had, we got the best results we could. And this helps the model, along with the data, to sort of come up with the correct prediction. And then, of course, you need to know if the prediction it's giving is actually a good prediction or not. So there's things we call the metric scoring metrics. And there's a lot of them, but we chose the one ROC-ORC because it was best applied to our model. And basically, simply, I mean, you can see here that we either have 1 or 0. So logically, we want to get as high as possible to 1. In this example here, so basically, we see this graph here, and the area under the curve is calculated as, in this example, the 0.79 org score. In our case, we got a similar result around 0.8, which is good considering that we only had 2 weeks and limited resources and data. So we were very proud of that result. Yeah. Good. And yeah, here you can see basically that we were able to get a data set of 500,000 flights, which each had 30 criterias of, for example, the airport, the hour, the weather, and that's what we used to train the model. And in total, this was about 15 million data points. To give a bit of context, something like ChatGPT uses hundreds of billions of data points. So obviously, we could raise this exponentially by adding more flights, more data, and obviously that would increase the score and the predictive capability of our model. And yeah, just to iterate the point that we were using industry standard practices, for example, going to an API, which is basically, to simplify it, a source of information and getting the information from there, which is what a lot of massive companies nowadays use, for example, Google. And in this case, we use the API called Cirium, which is what Google uses as well. And in fact, we did a bit of research and we're looking at flights that were in Google, saying if they were delayed or not. And a lot of them are actually incorrect. And our model was actually, what we've tested in the last day, 100% correct. So without being too arrogant, we can say that our model is doing better than Google. So anyway, thanks guys for listening, and I hope you enjoy Will It Fly.